Hello everyone. All right, so this is going to be our last week for the video recordings, because the next 2 weeks is a review and the final exam week. Okay. All right, so we're going to cover quadratic equation, and we already touched on the quadratic equation on week 9 when we did factoring. So you already know how to do quadratic equation using factoring, okay, with the zero product rule and so on. Now we're going to get into 3 methods, which are the quadratic formula, the square root method, or property, or completing the square, and then we're going to go through how we graph a quadratic function. Okay? All right, so let's get started. So let's just get started with the first one. Oops. The wrong screen there. This is the one. All right, so let's get started with this problem, and we're going to use quadratic formula. Okay, and the formula is quite simple, right? So it's simple. You just have to remember it or have it in front of you. All right, so it's going to be x is equal to negative b plus minus square root of b squared minus 4 times a times c over 2 times a. Okay, so now the question is, where is that b, a, and c come from? It comes from the standard form of a quadratic equation. So the standard form of a quadratic equation is as follows: is a x squared plus bx, so standard form, plus c equal to 0, right? So you have to have that standard form, right? Especially when we were factoring, you had to have it in that format as well. So all you're doing here is, when you have it in standard form, you're using the coefficient a, b, and c. Those are called coefficients, right? Any value in front of the variable is called a coefficient. Okay, coefficients a, b, c. All right, so we're going to be using those coefficients in the following equation. All right, so it's a hard one, not that hard, but you've seen it in your discussion, or at least as an example. So 4 over 3 r. So what we look for is r plus 3 over 2 equal to 3 over 2 r squared. Okay. All right. So so this one is all over the place, right? Is not in standard form, and we have fractions, right, as coefficient or constant. And so what we need to do, when you see fractions, you use the method of clearing out the fraction. You want to deal with fraction, so you need to have an equivalent equation. And so the first thing we want to do is find the LCD, right? And the LCD, so we have 3 as denominators, 3 and 2, so 6, right? 3 times 2, 6. So what do I do with the 6 here? I multiply all the terms. So we have 3 terms. I'm going to multiply them by 6. So let's do that. Let me use another color here. I'm going to multiply the first one by 6, the second one by 6, and the third one here by 6. Okay? All right, so the second step is the second step was to multiply all terms by LCD, right, which is 6. And then third steps will be to clear out the fraction, meaning we want to get rid of the denominators. Clear out fractions. And how do we do that? We use the LCD and we divide it by the denominators that we see here. So 6 divided by 3, 2 remain. 6 divided by 2, 3 remains. 6 divided by 2 again, 3 remains. Okay? No more fractions. So what do we have? What do we have left? We have 2 times 4 times r. That's 8r. Right? Then we have plus 3 times 3, 9, equal to 3 times 3 times r squared. That's 9r squared. Beautiful. Now, so we have simplified the way it looks, right? So it looks way better, but we still don't have it in this standard form here, right? So we need the standard form, so that we want the ax squared plus bx plus c. So then we want the 8r and the positive 9 to be next to the 9r squared, or the 9r squared to be next to the 8r plus 9, right? So either way you can. So let's move the 9r squared to the left side, and we're going to get negative 9 r squared, sorry, plus 8r plus 9 equal to 0. There's nothing there, so it's 0. All right, we have it in standard form. So all we need now is negative 9, positive 8, and positive 9. That will represent A, this will represent B, and this will represent C. Okay? And we just plug them into our quadratic formula. So let's make some space here. Right? And that's going to be, right, R. It's no more, because we look for R, equal to negative B, which is 8, plus minus, showing that we have two answers for this, right? Square root of b squared, that means 8 squared, minus 4, that's part of the formula, 4a, the letter A, that's negative 9, and C, times C, and that's positive 9. Let me go up just a little. Positive 9. Okay? And everything over 2 times A, 2 times negative 9. Okay? So now we need to simplify all that. And let's do this. Okay, it's going to be R equal to negative 8 plus minus square root of 8 squared, 64. Then here I have two negatives, so I know it's going to be positive, right? Because I'm going to multiply all of that. So let me just put the positive already because you have a double negative. And it's going to be 4 times 81. So then you use my calculator. 4 times 81, 324. So is 324 over 2 times A, negative 18. All right. So let me just go here. I'm just going to simplify whatever is inside the radical. And that's going to be negative 8 plus minus square root of, that's going to be 388. 388. Okay? Over negative 18. All right. So that should be your final answer, maybe. And we're going to see why. I'm going to, hold on. So it's going to be negative 8 plus minus. And then let's analyze this here, right? Because we need to simplify this. And so we need, within the factors of 388, we need to find a perfect square, right? Because that's what's going to enable us to simplify. So let's say first, if this is divisible by 4, right? Because it seems like there's an 8 at the end. Let's see if it's divisible by 4. And 4 is a perfect square. So 388 divided by 4. It gives you 97. And it seems like, so 4, square root of 4 times square root of 97 is, equal to square root of 388. Let's see, 97 seems like it's prime. So let me double check that. 97 divided by 7, by example. Yeah, it's 97. Yeah, 97 is prime. So this is not going anywhere, right? The square root of 97. So this is going to simplify itself to 2 times square root of 97. So instead of putting square root of 388, we're going to put 2 times square root of 97. And we're going to put it right here. Square root of 97 over negative 18. Now, it gets complicated. A lot of you, gets rattled about this here. So the best thing to do to simplify, because you have to simplify, because you have 8 on top, and you have 18, you have 2 and 18. So it's divisible, right? You can simplify this part. But in the simplification process, a lot of you get a little bit rattled. So you want to separate. So you want to do this, negative 8 over negative 18. Then you put the plus minus. And then you put 2 square root of 97 over negative 18. Separate them so you can simplify properly. So here, divide by 2 on top. That's 4. Divide by 2 at the bottom. That's 9. You have a double negative, so it's going to be positive, right? And here, you divide by 2. The square root of 97 stays as it is, but the 2 and the 18, they are integers. So 2 divided by 2 is 1. 18 divided by 2 is 9. Okay? All right. So, what do I do here? So it's going to be R equal to, and now because the denominator is still 9, I'm just going to put, so it's going to be positive here, right? And that's going to be 4 over 9. So I'm going to put the 4 first. And then I'm going to put the plus and minus. And then I'm going to put the negative on top. It should have been negative square root of 97. But because we have the plus and the minus here being represented, it doesn't matter. I can just put square root of 97. Okay? And then everything over 9. And that's your final answer, right? Final answer represents 2 answers, which is R is equal to 4 minus square root of 97 over 9. And then the other one, or R is equal to 4 plus square root of 97 over 9. Okay? So that's it for this one. All right. Now we're going to get to the second method using the square root property. Okay? And square root property just means that what we want to do is to isolate what we call the square terms, right? Square terms, there's only one square term here, and we're going to highlight that, and it's the negative 3x minus 7 squared. Okay? That's the terms that I want to isolate. Okay? That means everything else needs to be moved to the right side. Okay? So let's do that. So the 3 is going to be moved to the right side and it becomes negative 3, right? So I'm going to have negative times 3x minus 7 squared equal to negative 6 minus 3, that's negative 9. Okay? I could even do something pretty cool here because I recognize I have a negative here. I can divide both sides by negative 1, right? It will get rid of that negative here, so it becomes positive here. So it's going to be 3x minus 7 squared equal to positive 9. Okay, I'll just recognize that and I can do this. Now that I have 3x minus 7 squared, which is the square terms that I'm talking about, now I can apply the square root property, right? If it's square, then I'm using the square root. If it was a 3, then I will use the radical with the index 3, and so on, right? So I'm using square root of 3, so the square root, and that's gonna kind of cancel out the square root and the square. But now, whatever is inside the radical, because I have an x here, right? So it's as if I have a square root of x squared equal to 9, right? So this really means that I'm looking at the roots, right? The roots of x is either 3 or -3, right? Because if I square -3, it's going to give me positive 9. And if I square 3, it's also going to give me positive 9. So I have to represent the value of x, which is any real number, as either positive or negative. Okay? And we do that as follows. You put a plus and a minus right in front of the 9, and then you apply the square root. Okay, so let me, right? Then you apply the square root of 9. Okay? The plus and minus shows you that you have two answers here. Okay. So next step, the square root and the square cancel each other out. So we're left with 3x minus 7 equal to plus minus 3, right? Then I can solve for x, right? So this is just a simple equation. So we have 3x minus 7. So I'm going to move the -7. It becomes positive 7. And we get 3x equal to, so whatever, if you have a plus and minus, just leave it as the last term. And then whatever I'm moving to the right side, put it in front of the plus and minus. So I'm going to put 7 plus minus 3. Okay? And then I have to divide. So divide by 3 here, and then here I'm going to put the fractional bar under both of them, and it's going to be over 3. Okay. All right, so next, you divide, and you get x equal to, now I have two answers. The first one will be 7 plus 3 over 3, and the other one would be 7 minus 3 over 3, okay? So we have two answers. And the first one is going to be 10 over 3, so x equal to 10 over 3. And the second one is going to be x is equal to 7 minus 3 is 4, 4 over 3. That's it. Those are my solution. 10 over 3 and 4 over 3. Okay. All right. So now we're going to do a problem using completing the square method. Okay. The completing the square method, it comes from what we call the perfect square trinomial, right? So this is it here. The perfect square trinomial are those two expression. So you have a squared plus 2ab plus b squared equal to, and then it factors into a plus b squared, right? So if you have that format, then it's gonna, factor into this, right? So then the second one is a squared minus 2ab plus b squared equal to a minus b squared. Okay. So how does it come from here? Well, if you have any standard form of an equation, such as this one, then all you need in order to extend that into a perfect square trinomial is the first two terms, x squared plus 2x, x squared plus 12x, okay? And the x squared plus bx, or 12x, represent either, I'm going to show you here, the a squared plus 2ab, or the a squared minus 2ab. And in this case, well, because you have plus bx, it will be the first one. It will represent the a squared plus 2ab. And completing the square is the process of finding what b squared is, right? That's exactly what we're trying to find here. So here, we're trying to find the third term of that trinomial. And how do we find that? Well, I'm just going to tell you that right now. All you have to do is use the middle term, or the coefficient of the middle term, which is b. Very easy. Divided by 2, and then you square it. And that's going to be your third term. And that's it. That third term is b over 2 squared. Okay? And then if you want to, well, not if you want to, to factor it, you can use the b over 2. the first term would just be the square root of x squared, which is x. And then because it's a plus here, it's going to be plus. And then here, all you have to do is put that b over 2 here. That's going to be your second term of your binomial. So it's going to be b over 2 and then square. And that's it. That's all you have to do to complete the square, or at least put it in this format. Okay? So let's do this with this equation now, right? We're going to go through this process here first. Okay? That's our second step, is to go through that process here, find b over 2 squared, and put our third term. Okay? All right, so let's do that. So, where is b? B is equal to positive 12, right? And we're going to break that down. So that's 12, and I say we divide it by 2, right? And then we're going to square this. Okay, now, next step. So we found what the b over 2 squared is, the third term. Now let's go to the next line, because we're going to have to use the third term. The 35 is still there. So we have x squared plus 12x plus the third term, right, plus 35 equal to 0. But let's not forget, we added a third term, right, to this equation. This is what we're solving for. We're solving for this, right? And so if I'm adding a term, I need to add another term to balance the equation, right? I have to balance the equation, so I have to, the term that I'm going to find here is going to have to be on the other side of the equation, because they cancel each other out. Because initially, I'm still trying to solve for this, right? So I'm adding this third term on the left side, right next to the 12x, but I need to add it to the right side of the equation, okay, to balance the equation, okay? So very important. That's something a lot of people forget about. Not a lot, but some people forget it. I just wanted to stress that out. Okay, so now, what is 12 over 2? That's 6. What is 6 squared? 36. So we put, I'm just going to put in color here, 36 here and 36 there. Now, we're not going to rush and try to add 36 and 35. No, that's not the purpose here. The purpose is to find, because now I have this in perfect square trinomial, this whole thing here is a perfect square trinomial. Okay? So that means I can factor it. Right? I can factor it. So I can factor it, and I already know how to do it. I'm going to use the b over 2. I know it's going to be x plus b over 2, and then square it. So let's do that. So it's going to be x plus, what is b over 2? 6, right? So b over 2 is 6, and then it's squared. So I've done this part as well. Okay? And then I put plus 35, plus 35 equal to 0 plus 36, 36. Okay? So now we kind of recognize that, because we did that with the square root method, and that's exactly what we're going to do. We do this, we do the completeness square, so we can actually do the square root method. That's exactly what we want to do. Okay, so that means we want to isolate x plus 6 squared, move the 35 to the right side, and we're going to have x plus 6 squared equal to 36 minus 35, right? And that's 1. And let's take the square root of that. So I'm going to use the square root of that. And let's not forget, I'm taking the square root, so I'm representing two values, right? A positive and a negative for the x's, right? So plus, minus, and then the square root of 1. Don't put the plus and minus inside the radical. It has to be on the outside. All right, so now that the square root and the square cancel each other out, I'm left with x plus 6 equal to plus minus square root of 1 is 1, so we just put 1. Okay, then I'm going to move I just need x, so move the positive 6 on the other side, becomes negative 6. I'm going to put the negative 6 in front of the plus and minus 1. So it's going to be x equal to negative 6 plus minus 1. So I have two answers here. The first one is x equal to negative 6 minus 1, or x minus equal to negative 6 plus 1. So x is equal to negative 7, or x is equal to negative 5. So my solution set is negative 7, negative 5. All right, so we are done with the method of solving a quadratic equation. So now let's look at how to graph a quadratic function, right? So here we have y equal to x squared plus 6x plus 8. We're going to go through the steps on how to find it. All right, so first, the shape of a quadratic function is a parabola, right? So it's a U shape. We'll try our best to draw a U shape, right? They're always going to look like these two, right? Smooth curves, parabola, a U shape, go up or down, okay? And if we have a quadratic function in the following format, y is equal to ax squared plus bx plus c, right? A here, the value here, determines it determines the shape, whether the parabola goes up or down, right? So if a is greater than 0, meaning it's positive, then the parabola goes up. If a is less than 0, meaning negative, then the parabola goes down, right? So we already know, just by looking at the coefficient of the x squared term, how the parabola is going to look like, okay? And in this case, for us, it's going to be, this is a 1 here, right? So the parabola is going to go up. That's first indication. So in your calculation, if you end up with a parabola down, based on that value of 1, you know that you're doing something wrong. Okay? All right. So this is the first step, determine how the parabola is going to look like. And we know it's going to look like this. Okay? All right. Next, what we want is basically finding what we call either the vertex or the axis of symmetry. You know, they are kind of related. And the vertex and the vertex or the axis of symmetry, well, let's talk about the vertex. So the vertex is either the lowest point on your graph in your parabola or the highest point, right? So if it's, so for example, for this parabola going up here, the vertex will be the lowest point, and you see the dot that I have here, that will be your lowest point, so it's going to be your vertex. Okay? But if you have a parabola going down, that will be the highest point, right? And that's going to be your vertex there. Okay? So it is the highest point. How do we find that value? There is a formula for that. And so finding, so let me use the vertex is a simple formula, which is negative b over 2 times a. And then that's for the x coordinate. And once you find the x coordinate, you can plug it into the function f of negative b over 2 times a. If you don't understand this, I will explain it right now. So if I'm using this formula, then what is b? It's positive 6. What is a? Is 1. Okay? And the negative is part of the formula, so let's just find it. All right? So it's going to be negative 6 over 2 times A1. And I'm not going to do anything yet here. Let me simplify it. So the vertex is -6 over 2 times 1. That's going to be -3. Okay. So here I'm really trying to find what f of -3 is. You should know what it means, but all it means is that the y here really represent f of x. Okay, so this is a function notation, f of x and y just represent the y coordinate, right? So f of -3 is actually the y coordinate of a point. So that's why we have y here, but you can put f of x instead of y. Okay, and all it means is that if I put a value for x here, then all the value of x here is going to be replaced by that value. In this case, it will be -3. So let's find what f of -3 is. F of -3 is equal to 1x squared, or -3 squared, plus 6 times -3 plus 8. And we evaluate that, and we get -3 squared, that's 9, minus 18 plus 8. Okay, 9 minus 18 is -9. -9 plus 1 is -1. Okay, so my vertex is at -3, -1. That's going to be my point. Okay, so that means my lowest point on the graph, there shouldn't be any type of graph at the bottom of -3, -1. That's going to be my lowest point. Okay, so we already have that. Now, the axis of symmetry, and I don't know if you have to find it, but I'm just going to, so the axis of symmetry, it's a invisible line, and we're going to use it as a dashed line, right? That separates the graph in equal parts. So the vertex actually, is since it's the lowest point, it shows that on both sides of the vertex, those are equal parts, right? So here, I'm just going to put the vertex here. It's a dashed line. And so this part right here and this part right here, they're supposed to be the same length, but because I'm drawing it, it doesn't look like it's equal parts, but they should be, right, equal parts. Okay? And so that axis of symmetry shows that if I were to, fold at that axis, it would be equal parts on both sides. All right. So, and it's very easy since it's a vertical line that crosses the vertex. So that means that line has to be x equal to that value here that we found for the x coordinate, which is -3. Very simple. Once you find the vertex, the x coordinate is also that invisible line that represents the axis of symmetry. Beautiful. Now, so we have a point. We know how the parabola is going to look like, and then we have this imaginary line, which is the axis of symmetry. And now, all we have to do is find the intercepts, right? The intercept is when we have the parabola crossing the x-axis and the y-axis. Okay? And we need those points so we know how the graph is going to behave. Okay? And we should know how to do that because we know how to solve for a quadratic equation. So let's find, so number 4, find the x-intercepts, if there are any. Okay? And basically the x-intercept is when y equal to 0, right? If you remember when we did linear equation and so on, right? If we were to find the x-intercept, we just plug in 0 for the y variable, and then you find your x-intercept. Same thing, same scenario here. So the y here is going to be replaced by a 0. All right, so this is going to be replaced by a 0. So I can put this as 0 equal to x squared plus 6x plus 8. Okay, I don't have to put the 0 here. I can put it on the right side, right? It will be the same thing. All right, so this is a quadratic equation. Seems like it's factorable. If you want, you can use the quadratic formula, but we're going to factor in this case. So it's going to be x plus 4, x plus 2. Okay, which means that x is equal to negative 4 or x equal to negative 2. All right, so those two values represent the x-intercept, and we're going to write them as follow, as coordinated points, right, or ordered pairs. So it's going to be negative 4, 0, because the y-coordinate is always 0. And then the other intercept is going to be negative 2, 0. Okay, so far we have was the vertex point, the lowest point, and then we have two x-intercept, right? So we have two x-intercepts here. Okay, and we also have the information, and we also have the axis of symmetry. Okay, what else do we need? The y-intercept. Okay, so number 5, find the y-intercepts. And there's only one, so I don't need an S. All right, so find the y-intercept. And that's kind of easy because, right, in this case was when y is equal to 0, finding finding the x-intercept. The y-intercept is when x equal to 0, right? So now x equal to 0. So when x equal to 0, so y is equal to 0 squared plus 6 times 0 plus 8. So y is equal to 8. So my point is, so let's not forget x equals to 0. So it's going to be 0 for x and then 8 for y. That's my y-intercept. Okay? So vertex. So that's enough for me to graph my function. Okay? All right, so let's do that. All right, so first, let's plot the intercepts, right? So we have 0, 8. So like 1, 2, 3, 4, 5, 6, 7, 8. Okay? I'm not going to have a perfect line, but, I'm going to try. So 0, 8, that's my y-intercept. Then negative 4, 0. Am I doing something wrong? It seems like I'm doing something wrong. Because now I have, oh yeah, no, I'm good. I'm thinking, I'm confusing the y-intercept with something else. Never mind. I actually confused the y-intercept with the vertex, and I was like, I confused myself. Sorry about that. Okay, so the y-intercept is 0, 8. Perfect. Then let's go to the x-intercept. And the x-intercept is a negative 2, 0. So negative 1, negative 2. That's one of them. Okay. And then negative 4, 0. Okay. So you have the 2, negative 2, 0, negative 4, 0. Beautiful. And 0, 8. And then now I can do the vertex which is the lowest point, -3, -1. So -3, -1. And that would be my vertex. Okay? And then my axis of symmetry, right, would be that invisible line. We usually use a dashed line. So it's not perfect though. It's supposed to be vertical, but, right? So it passes through this point here, the vertex. And that's x equal to -3, right? So makes sense. We did the linear graphs, and a vertical line, you know, is always x equal to some value. X equal to -3 crosses the point -3 on the x-axis. All right. So now I can, because I know my parabola is curved at the vertex. So if it's curved at the vertex and it touches the x-intercept, so I can do as follow. I can do this. Okay, so I'm going to attempt to make it curve, right? And then go through the y-intercept, right? So that's my goal. And then I'm going to attempt to make the other side kind of equivalent, right? It may not be, but I'm trying. So it's just a kind of representation, but so that's it. That is it. You have, you know, you have your vertex, you have your axis of symmetry, you have the two x-intercepts, the three x-intercept, I'm sorry, and you plot it, and then you know how the parabola behaves, and you draw it. You don't have to draw anything for in Connect Math, but that's what it is. Okay? All right, let's move on to the last one. All right, so the last problem deals with the imaginary numbers or complex numbers, right? And so here you might see something like divide 12 over I, okay? So we know that I is an imaginary number that represents the square root of -1, right? So complex numbers are not real numbers, right? It's another set of numbers. And this is it. This is I is equal to square root of -1. Then as an extension, you can also square that I. So if I have I squared, then it just represents -1. Okay? In the past, in the real numbers, a negative number under the radical or an even index would not be possible, right? It means it does not exist for real numbers. But for complex numbers, it is being represented by the square root of -1. All right, so if you divide 12 over I, it's actually a square root. So you have to rationalize, right? So like in the past, if I had a 12 over square root of x, for example, I could not leave it like this, right? I had to multiply by square root of x over square root of x, and then I will have 12 over 12 square root of x over just x, right? Because it's square root of x squared, right? Because the goal is to get rid of that square root. But so here, the I represents the square root of a number. So we need to rationalize it, right? And so because it's just I by itself, just multiply by itself, right? Because it represents the square root. So multiply this by I, and obviously multiply the top by I, and then it's going to become 12I over I squared. And we know that I squared is equal to what? -1. So it's going to be 12I over -1. So I'm negating that thing here. And then finally, -12I is your final answer. Okay? So that's when you only have like one term or, you know, at the bottom. Now, if you have a combination, not a combination, you have a binomial, then you have to use the conjugates, right? So we talked about the conjugates. Basically, if I have a plus b, right, its conjugate is a minus b. You use the same terms, but one is a sum and the other one is a difference. Okay, so what I have to do here is to multiply this by the conjugate, which is 3 plus 2i. And I will have to multiply the top by 3 plus 2i. Okay? So when I multiply this, the I term is going to cancel out. And so let's do that. So I don't have to do anything on top yet, but let's use the for method on top, at the bottom, I'm sorry. So 5i first with the 3 plus 2i over 3 times 3 is 9, right? The outer 3 times positive 2i is positive 6i. And then the inner is negative 2i plus times 3, so negative 6i. And then the last term, negative 2i times negative 2i times positive 2i is negative 4. Let's not forget, we're multiplying the i's twice. So that means it's I squared, right? So it's I squared. As anticipated, the positive 6i and negative 6i, they are opposite, so they cancel out. And then let's replace the I squared with negative 1, right? Because that's what it is, negative 1. So it's going to be negative 4 times negative 1. That's positive 4. So next is going to be, let me erase this here so I have more space. So it's going to be 5i times 3 plus 2i over 9. And then here, if I'm evaluating this, that's negative 4 times negative 1. That's positive 4. Simplify this, and I get 5i times 3 plus 2i over 13. And those are my, this is my answer, okay? So I have answer for the first one right here, and for the second one right here. Okay? And that concludes this week 10 session.